So this is part 2 of 5.6, okay? And we are going to talk about slope. So something to understand, anytime you have a straight linear relation, they have something called a slope. And a slope is also known as a rate of change. And we can put a number to how much this thing is sloped, okay, or what the rate of change is. So this we will learn, and sometimes the slope have its meaning, pretty much all the time, in fact, especially if you have context. So you're going to be introduced to the brand new concept, slope. Now, what is slope? Well, slope is a ratio that compares the change of your dependent variables to your independent variables, okay? So essentially, it's a ratio, and that's all it is. Now, another way to think about slope is it's the comparison between the rate of change between your range values and the rate of change of your domain values. Okay, so here's a simple equation. Change in dependent variables over your independent variables, or the change in range over the change in domain. Okay, so if you can determine what the change of your range is, you simply divide it by the change of your domain. Okay, now something to understand, slope has context, or when slope is in a context, it has meaning. Okay, so it's important to understand that when a slope has meaning, it's given context. So I kind of just repeat myself, but it's really important to understand. And what you have to do, at least just in this chapter, is you have to be able to determine contextually what the ratio represents. Okay, something to understand, and this is really important. Slope is often referred to as the rate of change. Okay, so that's really important. Pretty much slope equals rate of change. And that's another way to think about slope. Okay, now here's some examples of when slope has a meaning to it. So an hourly wage, a hourly rate of something decreasing or increasing, an acceleration, a speed, sometimes it's your distance. So that's what rate of change is. Now here's kind of it mentioned below again. So again, the rate of change equals slope. They're interchangeable. Now, lastly, finding the rate of change for a given table of values. So first you determine the rate at which your domain and your range values are changing, and then all you have to do is you have to divide them. So when you determine this, then you take your change of range and divide it by your change of domain. Okay, and this thing equals slope. So let's figure out how to use this quickly. So given the following tables and graphs below, determine first of all, if the relation is linear, and then determine what the rate of change is and what it represents. So let's look at A here. So you guys know, hopefully by this point, how to figure out if a table of values is representing a linear relation. What we need to do is we need to figure out if our domain and our range are going up by constant values. So here we can see we have X, and this is our independent variables. And then our money depends on how many rides we ride. So this is our dependent variable. Making this, actually, these values are domain, and these values are range. Okay, now let's talk about how our domain is changing. So to get from 1 to 2, you add 1. To get from 2 to 3, you add 1. To get from 3 to 4, you add 1. So it looks like the change in domain equals plus 1. Now let's look at the change in range. So how do I get from 9.25 to 11? Well, in order to figure out what I need to add there, I'm going to actually subtract these two values. So 11 minus 9.25, that gives me 1.75. So if I take 9.25 and add 1.75, that gives me 11. So this is 1 plus 1.75. Now, from here, if I'm stating that this thing's a linear relation, that means this next jump has to be the same thing. So let's see if it works. Let's see if we add 1.75 to 11 if it equals 12.75. So 11 plus 1.75 does in fact equal 12.75. So this is plus 1.75. And remember, you have to check every single increment. So we can't just assume as soon as we find 2 because this could not be the same. So let's check. 12.75 plus 1.75. And look at that. That equals 14.5. So this, in fact, is plus 1.75. So there's our change in range. So the change in range, well, that equals 1.75. Now, what does this mean? So first of all, for I, we have determined that this thing is in fact linear because both domain and range are increasing at the same rates. So if I write I over here, this is linear, okay? Because our domain and our range are increasing at the constant rates here. Now let's figure out what the rate of change is. So let's write I here, and I'm just going to use this column here. So what is my rate of change? Well, remember, rate of change equals slope. Slope equals the change in range over the change in domain. So rate of change equals slope. And we just talked about how slope is the change in range over change in domain. So let's take the range values. The change in range, which we talked about, is 1.75 over our change in domain, which is 1. Now, something as a hint. Remember, given a context, our slope means something. Apply what the units are to this, and that can help us figure out what this means. So what is this top number representing? Well, it's the range, and the range is measured in dollars. Okay, so this is $1.75. What's that 1 represent? Well, 1 represents rides, so I'm going to put ride here. And we can already see that this tells us the rate of change. What does the slope represent? Well, the slope represents that every ride costs $1.75. So the rate of change, slope represents that 1 ride equals $1.75. And that's what your slope equals, and this is what your rate of change is, or your slope. Okay, so hopefully that was helpful on how to use a table to determine. Let's figure out how to use a graph. Okay, and a graph's a little bit more tricky, depending on how you feel about these things. So first of all, again, to see if a graph is a linear relation is pretty easy. Is your graph perfectly straight? So I is kind of done for us. The graph is straight. Okay, so since our graph is straight, it's a linear relation. Now, this is where it gets a little bit trickier. For II, what is the rate of change? So in order to determine the rate of change, we have to remember that rate of change equals slope. And what does slope equal? Slope equals the change in range over the change in domain. So what does that mean? Well, pretty much, how do I get from, say, this point to this point? Now remember, what is range on a graph? Well, your range is your vertical axis. So this is my range axis, whereas this is my domain axis. Okay. Now, how can I determine what the change in range is? We'll pick 2 points. So I'm going to pick these 2 points, here and here. And how do I get from this point to this point? Okay. So we need to know what our increments we're going up by here. Here we're going up by 20, 40, 60, 80, 100, 120. So we're going up by 20s. Okay. Here it looks like we're going up by 200s. 200, 400, 600, 800, 1,000, so on and so forth. So again, how do I get from this point to this point? Well, here we're going over 20. So plus 20 for our domain. Okay, so you can see we went over 20 on our domain. Now here's the thing. We're going downwards, okay, in our range value. So that means we're going minus. We're going from 1,600 to 800. So that's minus 800. Okay, and that would continue. To get from this point to this point, we have to go over 20 in our domain. So plus 20. And then we have to subtract 800 to get to our newest point. So it looks like our change in range. What does our change in range equal? Well, our change in range equals negative 800. What's the change in range or domain? Getting tongue-tied. The change in domain, we're going over plus 20 every time. So plus 20. And then from here, we can actually plug this in. So we can figure out the rate of change. So I'm just going to put it as ROC, so rate of change. And again, that's slope. And we just talked about what slope is. Slope is this. So we have to take and figure out the ratio of our change in range over our change in domain is. So this is negative 800 on top divided by positive 20. Now remember, to figure out the context, to figure out what this represents, plug in your units because that can be very helpful. So here, what's our range? Well, this number is measured in liters. So liters. And then our minutes is our domain. So this is 20 minutes. Okay, so you could actually stop there and say that the rate of change represents, and here we can see it's minus 800. So this is losing 800 liters every 20 minutes. So it represents a loss of 800 liters every 20 minutes. What else could we do here? We could actually simplify this. I could get this down to 1 minute. How do I do that? Well, I divide this by 20. But remember, if you divide this by 20, you divide this by 20. And that gives me 1 minute on the bottom. And here, now I can say, well, how much am I losing every minute? Well, here I'm going to go negative 800 divided by 20. And that gives me negative 40. So here I will get negative 40 liters. And that is another way to state my rate of change. Rate of change represents a loss. In this case, we're losing 40 liters every minute. So a loss of 40 liters every minute, every 1 minute. Recognize if you use this or this number, you will still be able to graph this exact same thing because this is actually the same rates, just represented in a different form of a fraction. So losing 800 liters every 20 minutes, that's the same rate as losing 40 liters per 1 minute. And there you go. There you have it. That's how you find a slope or the rate of change. Now, in chapter 6, this is going to get a lot more mathematical this is kind of your very, very intro level slope. So you want to come in and ask me questions and really figure out how to determine your slope and rate of change before moving forward, because this is a good kind of ground level understanding of what slope is. So go in, and now you have all the information, and we went through enough to go and check your understanding of 5.6. Open up your textbook or any other materials that I've given to you and see how you do. Make sure you're coming in and asking lots of questions and figuring out how to work with all of these new words, equations, and variables. Have a good day.